Hello! In this video, we will simplify trigonometric expressions, and for this, we will use some fundamental trigonometric identities we have here to the left. These include the reciprocal identities, the quotient identities, and the Pythagorean identities. We will also use some techniques for simplifying expressions that we use in algebra. When we simplify a trigonometric expression, we want to condense it and make it as small and simple as possible. Here we have three expressions, and the first one is sine of x times cosine squared of x plus sine cubed of x. This expression has two terms, and notice that both of them have sine of x. So let's try to factor it out. So we will have sine of x, parenthesis, cosine squared of x plus sine squared of x. So sine times cosine squared will give us the first term, and sine times sine squared will give us sine cubed. And now for the expression we have inside the parentheses, we will use the first Pythagorean identity where the value of this expression is 1. So again, cosine squared of x plus sine squared of x equals 1. Then sine of x times 1 is sine of x. And this is how far we can simplify the first expression. The second expression is tangent of x times secant of x times cosine squared of x. When simplifying trigonometric expressions, in many cases it is a good idea to rewrite each trigonometric function in terms of sine and cosine. The first quotient identity tells us that tangent of x is sine of x over cosine of x. So I will replace tangent of x with sine of x over cosine of x. Then, using the reciprocal identities, we will write secant of x as 1 over cosine of x. So in place of secant, I will write 1 over cosine of x. Then I will bring down cosine squared of x. And because cosine of x times cosine of x is cosine squared of x, it will cancel with this cosine squared of x. Then we are left again with sine of x. Now the third expression is cosecant of x minus 1 over sine of x minus 1. First, I want to tell you that in many cases, there is not only one path you can take to simplify a trigonometric expression. For example, I could start by multiplying both the numerator and the denominator by the conjugate of the denominator, which is sine of x plus 1. And because this may take longer to simplify, instead, I will rewrite each function in terms of sine and cosine. So in this expression, I will write cosecant of x as 1 over sine of x. So then, I will have 1 over sine of x minus 1 over sine of x minus 1. And now we got a complex fraction, and this is a fraction that has fractions. And now from algebra, we know that to simplify a complex fraction, we need to multiply both the numerator and the denominator by the least common denominator of all these terms. Now, the only denominator we see in all these four terms is sine of x. So then, we will multiply both the numerator and the denominator by sine of x. And now we need to distribute sine of x. And when we multiply sine of x by 1 over sine of x, then sine of x will cancel and we will get 1. So let's start a fraction and write 1. And now sine of x times negative 1 is negative sine of x. Then we will write minus sine of x. And for now, let's keep the denominator the same. Sine of x minus 1 multiplied by sine of x. And now let's see if there is anything to cancel. Is 1 minus sine of x the same as sine of x minus 1? No, they are not the same, just like 4 minus 7 is not the same as 7 minus 4. But what we can do in the numerator is to factor out -1, and then these two expressions will be the same. So then, if we factor out -1 in the numerator, then inside we will have -1 plus sine of x. And to check the work, -1 times -1 is +1, and -1 times sine of x is negative sine of x. Then I will copy down the denominator, sine of x minus 1 times sine of x. And now these two expressions inside the parentheses are the same because they both have positive sine of x and they both have -1. And this means that we can cancel them. And now we have -1 over sine of x. And to condense it more, we can write 1 over sine of x as cosecant of x. Then the final answer will be negative cosecant of x. So here we have all the examples simplified, and I hope you liked this video, and if you give me a like and leave a comment, I will really appreciate it. Thank you.